So in this demo for dynamic memory, the first thing we're going to do is make a dynamic array. So when you make a dynamic array in C++, so for an integer array, it would be it would be a type pointer. So we'll say int array, and then we'll use a new keyword to place this array on the heap, and we'll say new int, and then this bracket notation, and then here we put the size of the array. So if we have this size variable, then we'll say that it's an array of size 3. So again, what this is doing is we're making an integer array. We're allocating slots for like 3 integers in this array, and we're using the new keyword to put this on the heap. And what that means is that it's going to be allocated dynamically, and you could use this to make arrays of variable size. So for lab 4, you're not going to know what the size is at compile time, which you need for static arrays. For dynamic arrays, you don't need to know what this is until like runtime, basically. So that's why we do this. So now we're going to fill and print the dynamic array. It acts just like a normal array, so you can just do um, indexing like this. So you can assign this character to the first element and so on. And then we can do print string. So I think this should be a character array actually, because each of these are characters. And then we're just going to assign characters to each of the slots in the array. And then this print string function, which just goes through the array and it prints out everything in each of the characters as a string. So we can look at that. Oh, and this should be named dynamic array. Yep, so the size of this array is 3, and it just prints out all the characters in order. Now we're going to make a new array. Okay, so now it's going to be an array of size 6. So we're going to say dynamic array 2. We'll use this. And then we're going to copy all the elements from the old array, dynamic array, to the new array. So, in terms of lab 2, this is basically like how you do a resizing. So whenever you decide that you need to resize your array, you make a new array with double the capacity, and then you just copy elements from the old array to the new array, and then you would delete the old array, which we'll talk about also. So we'll say for 0 I less than 3, since there's only 3 elements in the old array. We'll do dynamic array 2 of I equals dynamic array I. So again, this is just copying the first 3 elements from the dynamic array into our new dynamic array. And then if we want, we can do something like, oh, we do this later. Okay. So we're gonna finish filling in the new array. So, we have a character array of 6 slots, six spaces. We filled the first 3. And now we're just gonna go ahead and fill the last 3. Okay, so now the whole thing is gonna print Gabby if we were to print the string. We're going to deallocate the old array now. So the way to do that is, since we allocated with this new keyword on the heap, the thing with dynamic memory is that it only lives, it lives as long as you like choose to keep it allocated in memory. So static memory, once you exit the scope, it immediately like gets destructed on its own. But like dynamic memory, that memory has to be freed by you. So you have to make the call to like deallocate it on your own, which you don't have to do with static memory. So it's like a new sort of practice you have to do. So to deallocate it, what we're going to do is we're going to do delete and then brackets and dynamic array. So the idea here is that dynamic array is this old array with like the size of 3 and the old characters, and we don't need it anymore because our new array has the you fix the names. Our new array has like the correct spots, sorry, the correct capacity, and we filled it. So this old dynamic array we no longer need because at this point it's just taking up a chunk in memory, right? So we're going to delete, and we're going to use the brackets here because when we allocated it on the heap, it was an array, and we used the brackets here. So if you were to do delete dynamic array without the brackets, it wouldn't work. This only works if you were to like allocate memory that's like not an array on its own. So if you were to just to do, let's say here we did character pointer and then C, you can do something like this. So what this does is it makes like a character on the heap. this character is just the letter A, but it gives us back an address to something on the heap, and that address is C. So note that in this case, dynamic array is a pointer to like an array of characters, basically. And here, C is a pointer to like a single character. So if you wanted to delete this character, you would do delete C. But for the array, since we initialize with brackets, we just call delete with the brackets after the delete keyword. And then the last step here, which is going to emulate like the resizing for ABS and ABQ, is to make our dynamic array variable pointer point to the new array, and then print out that same array. So we'll do. So again, remember that this dynamic array is just a pointer. So when we call delete, sorry, it should be dynamic array. So when we call delete on this dynamic array, it's freeing the memory there, so that like if you were to dereference the pointer, it would point to like an invalid chunk of memory, basically, because we stopped reserving that memory. So we can like it's pretty much inaccessible now. And if we try to access, if we would try to do like cout, or let's say we try to do print string dynamic array. If we do this now, note that what this does is it tries to go through the array that you pass in. So deleting this basically like renders the underlying data there. Like it deletes it, right? So this pointer is still like a valid pointer object, but it doesn't point to anything that's like valid memory, if that makes sense. Okay. So now what we can do is we can do dynamic array equals new array. So what this does is we move our old pointer to point to the correct memory. And this is like, again, this is literally like the algorithm for your resizing in ABS and ABQ. So again, once you get to the point where you have to resize, which again, that's when you reach the maximum capacity, you make a new array. So you prep this new array with double the size of the last array. And in your case, you would just do capacity, your current capacity times scale factor, which is 2.0, instead of hard coding it like this. But you make the new array, and then you copy everything over, and then you just delete the old array. Okay, and then you make your old array pointer point to the correct new array on the heap with the correct capacity. So this pointer assignment is just making our old pointer point to, once again, the valid memory that is like our actual data now. And then we're going to do this again, and then deallocate the memory. So now, since we have the second array that we like allocated, we have to delete that one too at the end. And the idea behind the deletions is that you just delete any variables that you don't need once you're done using them for sure. So since this dynamic array here we didn't need anymore, we deleted it. But we wouldn't want to delete new array yet, because new array is like our actual valid data, right? So once we're done working with that, we can only really delete it at the end of our program. So we can look at how this compiles now. Yeah, so the size of the first array was 3 and it had gap. And then, we copied everything over and then deleted our old array. And then our new array is size 6, right? With this new size. And that has all 6 characters. Okay. So that's all there is to dynamic memory. Just the main sophistications are like the new keyword and the delete keyword, and then knowing when you should be deleting things, and then how to like use the syntax properly with or without the brackets. So does anyone have any questions on any of that, or anything that was confusing? Okay, so if not, we'll move on to the big three. So the big three are like these 3 functions that you need to initialize whenever you're working with dynamic memory inside your program. And the reason they're important is because they help you handle like the dynamic they help you handle the dynamic memory that you might be working with inside a class. So if you make class variables that are allocated on the heap, then the big 3 are functions you implement to like help you like handle those and make sure that you don't have memory that like leak, for example, because back in this demo, if you weren't to delete these pointers, then you'd have what's called like memory leak. So you'd be losing like memory, and this would be handled by a computer, but like in your lab, it'll throw an error if you don't like delete all of the memory that you like allocate in the first place using the new keyword. So here we're gonna make the copy constructor, copy assignment operator, and destructor. So let's look at the first one. So what this does is it's just a different type of constructor, but it takes in a copy of a class. So if you have this class, meeting.pitch, right? For example, here, our default constructor just like gives default values to the variables, and parameter constructor assigns values that are passed in to those variables. Yeah, the copy constructor just takes in another class, and its purpose is to like copy all the attributes from that class to this class. Okay, so we'll do these. We'll do the default one. We can just set max capacity to 1, then number of participants to 0. And then all participants is going to be it's going to be basically like the character array from dynamic memory. So this is going to be like an array, even though it's a pointer, right? It's a pointer to an array. You can think of it like that. That stores like all of the participants in an array. So to initialize that, you would do all participants equals new, and then participant array with the max capacity, which in this case is 1, but this is also valid. So that's what this does. And then for add participant, what it does is, let's see. Okay, let me see what we're supposed to do here. So yeah, so it's gonna be, this is like a very similar model to, again, ABS and ABQ. So what add participant does is we're gonna try to add a participant to this array. And if there's like no available slots, so basically like if our size here is equal to our capacity, we have to resize our array. So we have to make more room for it. So we'll do, so this is void, because all we're doing is like we're modifying something. And then it takes in, let's say a participant, P. So all this does is, the first thing we're gonna do is check to see if this array is like full. And what full means in this case, right, is it means, is this number equal to the maximum capacity? Because if it is, then there's no space in that array. So if we try to like index past the size that we allocated in another array, it's gonna throw like an invalid write or something like that. Okay. And what that means is it's like a Valgrind error, which you'll be seeing in lab 4, and it means that like you're trying to write to somewhere that you don't have like access to write. So we'll do an example here. We'll just like run through this. So we'll say if number of participants equals max capacity, here we need to resize. Okay. So we need to resize. So again, what does that mean? The first step is we need to double our capacity and make more room. Okay, so we'll do max capacity times equals 2. Make sure. Yep, so we'll do max capacity times equals 2. And then I'm making sure that it's like a thing. Okay. Yeah, so basically the idea is we're going to resize the array, make the new array with twice the amount of space. And then once we have that new array set in place, we can then assign, our incoming participant to that now open slot. Okay. So we'll say if, yeah, so, if we have to resize, double the capacity, and then we're going to make our new array, right? So similar to how here we had dynamic array 1 and then the new array, this is going to be like our analog of the new array. So we're going to say participant pointer, and then we'll say new array. And then we'll say this is, again, a participant array, a new participant array, the new max capacity, which we have now doubled. Okay. And now we're going to copy everything over from our old participant array to our new one. So we'll do for an I equals 0, and I less than whatever the current size is, right? Because however many elements we have to copy over, that information is stored in this number. So I less than number of participants, I plus plus. Sorry. So yeah, we're just gonna copy everything over. So it's gonna be new array of I equals all participants of I. So this is the same step as this step. Okay, just copying from the new array to from the old array to the new array. And then once we do that, we don't need this old array's data anymore, because this is now a pointer to an array of size 3, whereas we now want to work with the array of size 6. So what we're going to do now is, do delete all participants. And we're going to set all participants now. We're going to set that pointer to point to the new array. So, this old array is now going to be rendered, it's going to be freed. So the data is rendered like inaccessible. And our pointer is now going to point to the correct array with like the updated capacity. And after that's done, we can just do like what we would do if we didn't have to resize, which is just to increment the size. So first we can like add our element into the array. So we'll just do all participants, and then the index is going to be number of participants here, right? Because, for example, if there's 2 participants, then the first open index is at the third index, which is index 2, because of zero indexing. So that's why we're using like this. And we're going to assign that. We're going to assign that to the incoming participant. And then we can just do number plus plus. So, in case we don't have to resize, then if we don't have to resize, then we actually still have space in our original array, which is why we can do this assignment. But if we do resize, then we're going to come back to here, right? Because all participants is going to like once again point to the correct array, whatever it is, whether we didn't change it or whether we did change it here to the new array. This is going to happen no matter what, basically. That's that function. Yeah.
So
No, it doesn't leave the variable. Yeah, so that's the whole point, right? Because the variable here, the variable is a class attribute. So deleting it, if it deleted the variable, that becomes bad in the class, right? So it just deletes the data there, like you said, and we can reuse that class variable. Because again, just think of this as a pointer to like where the array is, right? So we're just making the pointer like redirect kind of to like the new array. Yeah. So that's this function. Again, it's very, very similar to like pushed, I think pushed or like enqueue or slash compute, which we'll go over in depth, but it's really similar. And then the copy constructor, yeah. So what this is again, we're gonna make it's a constructor for a class, but the parameter is another class object, and it just serves to like make a copy of this. So what this looks like is it's going to be since it's a constructor, there's no return type, so it's gonna be meeting, and then we're gonna take in a reference to another meeting. Say m. And this can be a constant too. If you're looking to code, you might see constant sometimes, and this is the industry standard. But in general, we give you like the function headers. So if it doesn't have constant in here, then just keep it like non-constant. But yeah, this is going to be like the right hand side. So if you're to do, I'll show it in main actually. So I'll just do this definition. I'm going to show you in main. So the point of the copy constructor is, you might think that like, oh, when you do one object equals to another, like obviously you just copy all the member variables, which it does that by default, right? By default. But in this case, we actually want to do something different. So notice that if you're just to copy like all the variables from like some class object meeting to a different class object, you'd be copying the pointer all participants, and therefore your new class object that you copied, that's a copy of the old one. Their all participants pointer would point to the same array, which we don't want to do. What we're going to do here, so what that's called is a shallow copy. So if you have 2 class objects, but they have like pointers that are pointing to the same like, heap memory. Again, heap memory is just this array that we put on the heap, which is dynamically allocated. If they point to the same memory, then like let's say you have one object, you try to modify that object's array. The other object that you used to copy that, its array will also be modified because you're modifying the same array, even though they're like different pointers, if that makes sense. They're different pointers, but they both point to the same thing. So what we're going to do is that we actually want to make what's called a deep copy. And in order to do that, what you have to do is you have to make a brand new array, basically, and then have your all participants point to that array instead of the same array. So, like I said, C++ gives you like a default copy constructor. So what it would do by default would do max capacity equals m dot max capacity. Okay. it would do number of participants equals m dot number of participants, and it would do all participants equals m dot all participants. So this is a problem here, right? This pointer is pointing to the exact same array as m, whereas in reality, we want to make it point to a different array, which just has the same elements. So it's just like a copy, sort of. So instead of this, what we're going to do, this is wrong. This is shallow copy. So to make a deep copy, we're going to do all participants equals new, and then participant array. And then the size is just going to be this number of participants, right? Because it's the same size, right? It's storing the same data, but we're just making a new array so that like we have two different arrays in memory instead of just one, and then having like two pointers pointing to the same thing. So we're just going to make a new array with the same sort of qualifications. So new participant and then m dot max capacity, and then copy. So for in I equals 0, I less than the number of participants. So we're just going to do copying. So we're going to do all participants, I equals m dot all participants, I. And then there's no need to delete anything here because this meeting that we're passing in here is a reference. So if we were to delete all participants, or like if we were to delete m dot all participants, for example, we'd be deleting like class memory. We'd be deleting memory of like a class object that exists, which we don't want to do. Really delete the memory that you don't need anymore. But like if you're to use this like meeting object that you pass in somewhere else, then you definitely don't want to delete its like dynamic memory. So that's all this really does. So does anyone have questions on like how this copying is different from like the shallow copying that is discussed here? Like, do you guys understand that? Okay, so that's the copy constructor. The copy assignment operator, it sounds like a long name, but it's really just like an operator overloader for the equal sign. But it's in a different context than the copy constructor. So let me discuss something real quick. So if you look at these lines, let me uncomment these. So here we have a meeting object, and then let's see. So here, what this does is this invokes the copy constructor. So this is the same as doing meeting copied object equals original object. So these are the same thing. If you want to refer back to the syntax for constructors from lab 2, you can see why those two are like the same thing. But what this does is this is a copy constructor. This is invoking that copy constructor. And for the copy assignment operator, that gets invoked when you already have an object that you made, and then you're copying it like after construction. So basically, the difference is like at what point do you like make it a copy? So in this case, we're making it a copy at the time of initialization, at the time of construction. But in this case, when we do assign object equals original object, we already have this assigned object here, okay? And when we do this, we're working with an object that has already been constructed to begin with. So the difference is literally just like, are we working with an object that we already made, or are we like constructing it like as a copy to begin with, okay? So that's the only difference between these two. So for that reason, the code is going to be like really similar. The only difference is you have to account for like, okay, so what's going to happen if we already have an object that exists? So we'll explore that now. So we'll do, so this is going to return a reference. So it's going to be meeting ampersand, and then operator equals, and it's going to take in another meeting reference, right? Just like this one, where this is the right hand side of the expression. So I'll do RHS here, even though here like this meeting m is also like the right hand side of like the expression, here for example. So what this does, the only difference in these two is we have to see what happens if like our current object or this, right? If the object invoking this function call already has existing memory. So this all participants, you'll see that the constructor gives it like dynamic memory to begin with. So what we can do is we have to delete this first, basically. Okay, so we're gonna do delete all participants. You can only do this if it's guaranteed that all participants, like anything that you're deleting, has been allocated with the new keyword. But this is guaranteed because again, when you're inside this function, you're you're working with an object that you already made. You already made this up here, and then we're assigning it. So since it's already made, its default constructor has already been invoked, which means that its all participants does indeed point to dynamic memory here. So we're going to delete that first. And then after that, we're just going to copy this. I'm going to copy this, and then it's going to be the same process, right? Because once we delete that, then, okay, we're just going to like reassign all the memory variables to be the one of the right-hand side, and then do the copying. So they're very, very similar, but it's important to understand like how they're different and when you see like a line of code like in here, for example, you know that like, okay, these two lines are calling copy constructor, but this line is calling the copy assignment operator. It's important to know like why that is. So do you guys understand the difference between those two? Are there any questions on that? No? Yeah? Sorry, can you repeat that? It's kind of hard to hear. Yeah, yeah. So in this case, we have to do a deletion because all participants like already exists because this object was already like constructed. What I mean by that is if you look at main, okay, so we can take a closer look at this. So just to give you guys context, we made like a meeting here. I know I haven't finished this, but we'll come back. There's only like one more function left. So for context, okay, we have a meeting object, okay, and we added these three participants, Gabby, Artie, and Mason. So when we print the original object, it's going to print Gabby, and then Artie, and then Mason, because our print participants function, it just loops through our array, right? And it prints out each of the names there. So that's what that does. And then this is going to print out, yeah, so we did that. And then this calls a copy constructor on copied object. So again, this is invoking a constructor because we're making a new object and we're passing in the object that we want to copy. So in this case, copied object doesn't have like an all participants pointer because we haven't constructed it yet. So at this point, we're constructing it like from the beginning of its lifetime, if that makes sense. In this case, we have an assign object. We've already made this. So since we made this, it's already gone through like this constructor. And it already has all participants pointing to some like memory on the heap. And when we do this, um, if we were to exclude this deletion here, we basically be leaking memory because we're going to be reassigning our all participants pointer to point to something else, but the memory that we were pointing to initially hasn't been freed yet. So that's a memory leak. Okay, so we need to delete that first before moving on to something else. Because like in practice, like if you use like a lot of dynamic memory that you don't delete, you're just gonna have like holes in your memory, kind of, right? It's gonna be like bad for your RAM and stuff. So that's why we need to like free that memory first. Does that make sense? Okay. So yeah, that's that. And then the last thing is to return the reference. So we just do return this. Like I covered last week, this is just the address of the object invoking this method. So in this case, this is a pointer to assign object, right? The left-hand side, like we've discussed. And then we just use this operator to dereference this to the actual object. So we're just returning that as a reference. And this is more just like of a thing of convention. You might be asking like, oh, like, do we really need to return anything? Because this is like a lot like the plus equals and minus equals operators from, lab 3. In those cases, like I said that we could either do it void or have it like return a contact book reference. The truth is that it doesn't matter, but sometimes like the standard is that like you make it return a reference because sometimes you might like use this statement itself as an object. So you might use the return value of this if you're to use this as like if you were to input this assignment directly into something, which is sometimes used, then it would have to return something, which is why here we're going to return a reference. So, just for now, just take as like a thing of convention. When you're implementing the copy constructor, you don't return anything because it's a constructor. But for a copy assignment operator, you just return a reference to the class, okay? And then include return star this. this return statement is identical for all copy assignment operators. And the last thing is the destructor. The point of the destructor is to clean resources. So, again, whatever memory that like our class object might have allocated dynamically, we want to like clean that up. So the destructor of like an object is called at the end of a program for static memory, right? Any static objects like an integer that you like put on the stack, right? The stack is where static memory is. Any of those have their own like deletion processes that are like automatic because they're static. But for dynamic memory, it's not automatic. In this case, we'd have to like just make sure we delete any dynamic memory that we have. So all it's going to be is the function header is going to be a tilde and then the class name. So it's going to be meeting and then no arguments. So again, that means that like the tilde just signifies that you're working with a destructor. And then just going to be delete all participants because that was the only memory that we allocated dynamically for this class. One thing to note is that you can't actually call this destructor anywhere. So in main, it wouldn't be okay to do like assign object. The destructor of this object would be called as soon as you exit the scope. So once you exit the scope, it's going to be like, okay, let me now go into this function and then see what I have to do. And then here it's going to be like, okay, I have to like free up all the memory that like, we used in the heap. So that's what that does. And for most cases, your destructor is going to look like this. Or if you have like an array of objects that you individually allocated dynamically, you'd be looping through that array and then deleting each of those objects, if that makes sense. But then that would look like delete without brackets. So very simple. It's just a tool to like handle potential memory leaks like when you leave the program. So yeah, that's the big three. So you guys have any questions? Okay, so let's move on to the lab now. So let's see. So yeah, so for this lab, you have to implement like a stack and a queue, and those are just data structures, um, which the functionalities are described in these instructions. So a stack just has this like LIFO behavior where you put something to the back, and then when you remove something, it only removes from the back, and you can't randomly access elements in the middle. So it's like sort of limited. Then the queue is like similar, but like kind of the opposite. So you can only put stuff in from the back, but then when you remove stuff, it removes from the front. So obviously like this is like a queue, like in real life, like a line or something. And the stack is like a stack of books. So like you start putting books down, and then if you want to like get a book from the stack, you have to like remove the book at the top first. And you can't like pull out a book from the middle. And assume that that's how it works because you can't do random access. So to implement these, you have to use arrays and not, you know, the standard library stack and queue. Um, so you have to actually like you have to implement this using like arrays and like dynamic memory instead of using like a vector or something like that. Um, the functions again. So these functions are here. I'll like run through them. Um, for the ABS, this is the default constructor. This is the parameterized constructor. These are the big three, which we just covered. This push function is kind of like, if you look at our demo, it's kind of like our add participants function. We're going to be pushing something here. In this case, it's going to be a template, type template. You guys have done templates, right, in class? You guys are familiar with templates? Okay. So you don't work with templates. So, it's going to be some generic data here that we're going to be pushing in. And just like in this demo, right, you're going to be checking to see, sorry, this demo, you're going to be checking to see whether we need to resize our array. In this case, our array is just going to be, let's see. It doesn't tell you explicitly like what to name your array variable in this case, but it's going to be of type t pointer, right? Because it's an array of like the objects of type t, where t is just like a template. So it's like arbitrary data. Um, but it's a t pointer. You can name it like whatever you want. Um, yeah, I'm just realizing more and more that like the class is very similar to this. So you have like a size variable, which is like number of participants. And then you have a capacity variable, which tells you like how big your array is. So it's very, very similar, like super, super duper similar to this. Um, yeah, push, add something to the back. So check to resize. If you have to resize, then resize, and then push. What pop does is it removes an item. So pop is like the opposite. So you have to like remove an item and then see if you removing the item makes you go below half full. So if you go below half full, then we have to resize the array, but instead of making the capacity double, we make it half. Okay. So all that entails is, you know, the element that you're going to pop is going to be at the end of your array. So it's going to be at like the last index. And you know how to find the last index of an array or like whatever the last index is. It's just the size minus one, right? So you're going to delete that element, not delete, but you're going to sort of ignore that element. What you can do is you can make your new array with half the capacity and then just like copy over all elements, excluding the last one. So, for example, do a quick example. Let's say you have an array here of integers. So two, and let me just change my screen share. So let's say you have an array of 2, 3, and then 4. And the last one is blank. Okay, so this array has like a max capacity, or sorry, we'll do this. 2, 3, blank, blank. So this is a stack, okay, like a model of a stack, and its last two elements are blank. So the capacity equals 4, and the size equals 2. So the condition for like resizing when you're popping is whenever the size is about to go below half of the current capacity. So if we were to pop this 3, what you would do is you just get rid of this 3, right? And by getting rid of, all I really mean is you make a new array, right, with half the size, then you just copy 2. That's all. You don't copy the 3. That's the same as like excluding the element, sort of. There's no sort of deletion here because these variables themselves, you can't delete them. We only like allocated the array itself on the heap, but it wouldn't make sense to like delete the individual elements. You have to delete like arrays basically. So you wouldn't be using delete here. You just have to like sort of exclude it, if that makes sense. So make a new array and then instead of copying 2 and 3, just copy up to 2. And then what that's equal to is that's the same as copying up to your current size minus 1. Okay. And once you're done with all of that, you would just, um, decrement your current size. That's all pop is. Peek is really simple. Just return the element at the top of the stack. So that's the element in your last index. But you're not removing anything. You're just, returning it. But also, I should say for the pop function, you have to return the element that you actually like are removing. So one thing you might want to do or think about is how am I going to save the element that I'm like removing, before I like make the new array and then exclude that element. So you might want to save that in like a variable beforehand or something like that because you have to return that. And if you try to, make a new array like we did in like the paint I showed, if you try to return the element in like the new array that you purposely excluded, it's not going to be returned because it doesn't exist in that new array. So that's something to like be mindful of, I guess. And then obviously throw runtime errors if there's nothing in those arrays. So if the size is 0, right? Obviously, like your size is going to be running, so you're going to be incrementing the size when you push and decrementing when you pop. So if it's 0, then there's nothing in the array, and obviously um, you can't return anything. So it'll be a runtime error in that case. And then these are just getter functions. And then get data, you just gonna return your like pointer variable that points to your array. So in this case, you'd be returning all participants, for example. A queue is like the exact same except for that one behavior, right? So when you dequeue, instead of returning from the instead of like popping from the back, you pop from the front. What that means is if you're to go back here to our little uh, makeshift paint array, um, so instead of removing 3 here, you'd be removing 2, okay? And then your new array would look like this. Uh, but one thing you might want to do just so that like the array starts from the beginning of the array is shift everything over by 1 every time you make a deletion. So just to give an example where you're not going to be like resizing, let's say we have a 4 here, and then we just want to DQ here. Okay, so we're gonna get rid of this too. What you might want to do is instead of just like keeping instead of like turning the array into this, comma, 3, and then sorry, it's hard to draw 4, and then blank. Instead of doing this, you probably want to make it like this. So move all the elements back. So 3, comma 4, and then keep those last two blank. Okay, so that like every time you need to pop, or every time you need to DQ or peak, you're always just reliably pulling the element that's at the first index, and that's guaranteed to be there. If you move all the elements back like postemptively. And to do this, you did this in the contact in the lab 3 assignment. So, when you remove a contact, you'd have to like remove take all the elements afterwards, and then like move all the contact pointers back by 1 in the array. So you're basically doing the same thing here. I think this is like the easiest way to handle the dequeuing. You can also do a snake approach where you have it structured backwards, and then yeah, there's multiple approaches if you're to like draw on your own. Um, but I think this is the simplest one. It just involves like doing that shifting over, like I said. But we all know how to do that because of our remove function. So that's the only caveat. Otherwise, all of the functionalities. Sorry, I just stopped sharing. Um, Otherwise, all the functionalities for the other functions are exactly the same. Like for peak, again for peak, instead of returning the last element, you'll return the first element in the array, which is just index 0. Okay, and that's all that is. And then since it's templated, there's some additional syntax that you have to be mindful of when you make it the functions. Um, but that stuff is all covered in like the template demo and in like Podio lessons, I believe. So